So, Monday night I wasted an awful lot of time watching it. It does say debates in the title. Apparently it wasn't supposed to be a debate, it was supposed to be a discussion. A discussion on science. Oh dear. Geostrebe, which is German for Earth Nerd, versus JM Truth, which is English for J Molto Confused. What's on the screen right now was Geostrebe sharing a thing. This Joshua guy brought up, well, he said the longest photograph ever taken was 1,100 miles. He previously claimed it was 1,200, which is bollocks, as Cool Hard Logic will put it. But people looked up the actual world record longest ever photograph, which is Pic de Finisterre in the Pyrenees to Pic Gaspard in, it's France or Switzerland, I forget which. I should have that up in a tab. Let me bring up a tab and show you Pic Gaspard. And he said it's a globe killer, and he used a cheap excuse for a curve calculator to prove that it should be hidden behind this much curvature. Failed to take into account the height of the observer and then put it in feet instead of meters. Apparently the difference is a bit confusing for him. He asked how we can be sure what we're seeing is the tip of the mountain. Well, you can be pretty sure you are seeing the tip of the mountain. It's the top. Where else would it be? And asked how we can be sure we're not seeing the whole mountain. Well, that's Pic Gaspard, and it was viewed from about this direction, because the Pyrenees are somewhere off in kind of this direction. Why can I be sure you weren't seeing the full height of it? Because there are a whole lot of other mountains in the way, that's why. And then he said, then the curve calculator came up, the proper one, the one that actually works. This one, Walter Bislin's, and the Metabunk one. Walter Bislin's being even better than Metabunk. And he said maths doesn't prove anything, when it previously said it proved the Earth wasn't a globe. This is Geostrebe using Walter Bislin's curve calculator. Oops, wrong button. And about to figure out what he's got wrong.
10 too much in there.
Yeah.
Oopsie.
He put his altitude at something crazy.
Much better.
Now it's making sense.
So, I have a question for you, Gio.
And that's Joshua confused.
We live on a globe, yes?
Easy question, wasn't it?
Yes.
How clouds are flat?
Is that a question? How clouds are flat.
What?
How come the bottoms of all
this cloud.
clouds are flat?
Ah, damn. Just go back and...
How clouds are flat?
What?
How
There we go. Oh, is that perfect or...
come the
Tried to make this before and just accidentally caught Craig at full. What the fuck? What did this nutcase just say? Facial expression, but may not have timed it perfectly this time. Anyway, how clouds are flat? That's his question.
bottoms of all clouds are flat?
Well,
The
no they ain't,
bottoms of
pal.
the clouds are flat because basically that's...
I've seen some clouds that weren't flat underneath.
For the...
Approximately flat. Geostrebe is explaining why they're approximately flat. Why the cloud forms at a particular
flat
elevation.
cloud on a ball.
Again, what
This idiot.
exactly do you mean by flat?
It's trying to insist that...
Okay. If I'm looking out in all directions, I should see curve visually as I look out over the horizon.
Curve in which way?
Which is what you
The
do. You
cloud-
actually see the underside.
Let me finish.
Yeah, sorry.
Clouds
He's been like that the whole
also
time.
then should
Interrupts a
curve
lot.
according to the curve of the Earth.
And then complains when people complain about him interrupting.
Yes. No, they do. You can actually see the underside of the clouds. And you can actually
They don't-
see the underside of the...
This is Geostrebe talking about it curving away from you.
Curve.
He just
You
gestured
should see
side
a
to side.
curve across the horizon.
Right, that's enough of that crap. He just said you should see a curve across the horizon. So basically it was a waste of time. He's a waste of space and oxygen and protein and drinking water and quite a lot of other things. Possibly he's been drinking the tap water in Flint, Michigan. And it was a waste of everyone's time. Except this guy's. This guy wasn't really there. But he did give us a few laughs. One good laugh. This guy claims to be a real expert. Look at the way he's sitting. Just makes me want to hit him in the face with a baseball bat. And I'm English. I should be using a cricket bat. He claims to be an expert on spotting fake photographs. Claims to be a filmmaker, a producer of photography, an expert in all kinds of things, that master in science. And this is his website. Antarctica is allegedly not more than 12,000 miles around, comma. However, Captain Cook and Captain James Clark Ross, it's a lot of names for one guy, took 3 years and clocked 50 to 60,000 miles in circumference. Yeah, this one is bullshit, and how it is bullshit has been pointed out before. Their total distance that's quoted every time someone brings this up is from Britain, down the Atlantic, round a few islands, across to explore a bit of coast, round Antarctica, go and look around New Zealand, explore a few more islands, and come back to Britain. It wasn't just, you know, from the Antarctic Peninsula, once around Antarctica, back to the Antarctic Peninsula, and stop. Airy's failure, that's not how you spell airy, and it should have an apostrophe. Proves we are not spinning or moving at all. No, it doesn't. It started by accepting that we're moving and tried to prove the existence of luminiferous ether, and failed. It wasn't trying to prove movement, it accepted movement, tried to prove the ether. It didn't find any. No one ever has done. The photo below of the reddish moon, this is why I even looked at this website. Geerstraber pointed something out about this website, and it's this photograph. Proves water doesn't curve. The reflection of the moon should not reach us due to the curve of the earth blocking our view. What the... If you're on a perfectly polished flat surface, you would get a perfect reflection of the moon. If you're on a perfectly polished sphere, you would get a very slightly extended reflection of the moon. We're talking about a sphere 12,700 or something like that kilometers across. And that is not photographed from high up. You can actually find this photograph. Right click on it, copy image location, do an image search for sunset. Yeah, sunset, not moonset or moonrise. Click on a little photo that comes up and paste in the URL of that image, and Google will kindly find you a much larger version. Oh yeah. What Geerstraber pointed out is that the colours are wrong, the lighting's wrong, and these crepuscular rays, here and here and along here, the edges of the shadows of bits of cloud are pointing at a place that this moon isn't. Now I thought this moon had been superimposed in front of the horizon, which is incredibly sloppy, but no. You've got JPEG artifacts all around the moon, but also all around the bench, so never mind that. It just makes it slightly, and around the cloud edges, slightly hard to see what's been superimposed and pasted where and how. But this is actually reflected light here. But like I said, if you had a perfectly polished flat surface, or a perfectly polished oblate spheroid, or sphere, or prolate spheroid, or toroid, or Klein bottle, you get a perfect reflection of the moon, just very, very slightly distorted by the curvature in the mirror. Like you get when you go to a fun fair, one of those houses with the silly distorting mirrors in it. You know, you get to see your reflection, you're not hidden behind the mirror. Like, how would the reflection of the moon be hidden behind the curve? Just, this guy claims to know about cameras? Oh yeah, he claims to know about cameras. He said he had hundreds of videos where he'd brought boats back into view from over the horizon by zooming in on them. When asked to show one, he said he didn't have any. Then later, when a different video that actually does exist, of boat beyond the horizon, someone zooming in on it, not changing how much of it shows above the horizon, was played, he said zoom doesn't count, you can't use a zoom lens, you've got to use fixed zoom length. But he didn't change lenses, he zoomed in for the ones that he said he'd made, which he couldn't share because he didn't have them. It's a little bit on the thick side of pig shit. Anyway, This is a moon painted onto a sunset picture. And what you can see here in this picture, these dark and light stripes, well not that one because that's part of the bench structure, but that dark stripe, that one, 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 and that one, and that one, that one, that one. All of those dark stripes are dark because they are places where the water surface is tipped so far towards you it's not reflecting bright sky at all. All of these really bright bits here, which notably have dark strips in between them, little bright twinkly edges here, are places where part of the water surface is at the right angle to reflect the sun. Yeah, it's sun. Now up here it says Roger's moon, but believe me, the search came up sunset. I miss you sunset. It's been painted on. I think it's been painted out just there. I mean the sun been painted out just there. And the thing is, if you use Metabunk for example, how far above water do you think that is? 3 meters? How far away is the horizon? 7 kilometers, maybe? On a 40,075 kilometer circumference, 7 kilometers is a really tiny angle. It's like 0.062 degrees, right? If the wave surfaces are tilted more than 0.062 degrees, maybe they're tilted 0.1 degrees from level, then curved or flat or whatever shape, they're curved, they're tilted more than the curvature in that distance. So of course part of the wave out there at the horizon is at the right angle to reflect the same thing, same light as is being reflected by part of the wave here near your feet. So his whole attempt at proving anything with that is what cool hard logic would call bollocks. However, his thing about clouds being flat. Well, here's a cross section of a bit of earth and some cloud. It's to scale, really. I drew circles. I selected a circle, inverted it so I was only painting on the outside and did the grey for the cloud, then selected a smaller circle and so I was only painting on the inside and did the black for the earth. That is not exactly the correct radius because it's very, I don't have 16 terabytes of RAM here. It's kind of hard to get a full-size scale drawing like this. It's roughly the right radius for Earth. And on it I have drawn in Yorkshire Dales, width of the Vale of York, height of the North Yorks Moors. I haven't bothered colouring them in because I wanted to leave the sea level curve visible. I haven't drawn the Dales or the Pennines out here because I wanted to leave the sea level curve visible there. I have marked in, for the fun of it, Scarfell Pike, that's the one. Arudva, Ben Nevis, Mount St Helens, Mount Rainier. Yes, it is that much higher than Mount St Helens. Even though a photograph has Mount St Helens at a higher angle of elevation from the viewer. Oh yeah, that's because of curvature, Mont Blanc and Kilimanjaro. However, this nice diagram with this red line of sight up to this arrow saying, why, with clouds over here, asking why I can't see curvature from that. You do get clouds that high in England, you get very pretty little rainbows in them where the tiny ice crystals are refracting the sunlight. It's beautiful. But not today. Today, Leeds Bradford Airport has 3,800 feet, a few clouds at 3,800 feet, and it's forecast for tomorrow. Actually, that's forecast for today, that's a bit weird. Forecast for tonight, few clouds at 3,500 feet, or 1,066.8 metres. So I have marked in clouds here at 1,070 metres, because that's near enough to scale on this. So his line of sight to the clouds would actually to here, if it was a continuous cloud layer. Right. Get rid of all that and have a nice relaxing blue. Well, it's not relaxing if you're used to windows crashing on you, but soothing for the eyes. And some numbers. This is rechneronline.de. They have a radius calculator. Just put in your latitude. 54 is a very English latitude. Also a very wet latitude and a very North American latitude and a very many other countries' latitude, but this little bit of it, English. 20 metres above sea level, so that's your sea level radius, that's your eye level radius. And do it again at 1067 metres above sea level to get a cloud level radius, although it says ground here because it was never meant for clouds. This gives me 3 radii: radius 0, radius 1, radius 2. Metabunk will tell me the angle down to the horizon, 0.0024 radians with refraction, 0.0026 without. Horizon distance over 18 kilometres with, 16 3/4 without. Refraction makes the Earth appear as if it was opened up at the opposite point and spread out, so that there is kind of a blank area opposite you, into a larger ball. In this case, with standard refraction, 7/6 of the size, the radius and diameter and circumference. Which means refraction makes the Earth look flatter, which means that if you wanted people's photographs to appear to be photographs of a flat Earth, you want them to be taken when there's a lot of refraction, which happens when there's a lot of air density gradient, which happens when the air near the surface is very dense, which happens when it's very cold, which happens when the surface is very cold, which happens on those crisp, clear February mornings that flat earthers tell you to take your photographs. Quelle surprise! Anyway, I'm going to go with the geometric and ignore refraction completely. I'm going to get slightly different results from either because that's not the radius I'm using these radii. I'm going to do that because it makes this bit easier. This bit is far easier without refraction, because without refraction, lines of sight are straight lines. Radius 0, sea level. Radius 1, eye level. Radius 2, cloud level. The angle down from eye level to the horizon, which is called A, has a cosine that is radius to sea level divided by radius to eye level. So it's 0.0025 radians. It's in between the two values given on the Metabunk page. Slightly smaller radius because we are north of the average here. Distance from observer to horizon. This is just Pythagoras, 16 kilometres. Because I'm going geometric and ignoring refraction, distance beyond the horizon to the clouds is just in a straight line. It's another right angle triangle, the far side of the right angle. Both right angles exactly at the horizon. And it's another 116.5 kilometres, so the sum of them, 132.5 kilometres or 82.3 miles. So you could call this big problem number 1. That the clouds you see beyond the horizon, if you're looking out to sea from 20 metres above sea level, are 82 and a bit miles away. And that's without refraction. They're even further away with. That's quite a long way. Yeah. Another angle, I've just called it B, because I started with A. This is the angle above the horizon, not above eye level, above the horizon, to the clouds vertically above the horizon, and that's above at the horizon, vertical at the horizon, not vertical at you. It's a right angle at the horizon, again, building up a full square there. Height of the clouds above sea level divided by distance to horizon, and that is 0.067 radians, which is a much bigger angle than the angle of depression of the horizon, so they're above eye level, which should be no surprise. They're only 16 kilometres away. H. Right. This is the distance from eye level down to the centre of the flat circle whose edge is the horizon. Approximately twice your eye level elevation. This is why it was such a minor quibble with Bob. For these tiny terrestrial altitudes, 39.99994, just call it 40. You're 20 metres above sea level, that circle is 40 metres below you, or 20 metres below sea level. It's close enough to being the same thing, but I got the actual number there for the hell of it. Angle down to the edge, because when you look down to look at the horizon, you're not tipping down a cone, you're tipping down a plane. The left and right of your field of view stay level. So on the front that goes down, behind you goes up. So the edges of the horizon, while they're the same distance away, they are a lesser distance forwards. Cosine of how far out to the side they are. times as far in front of you. Dividing by that cosine, is that right? Yes, arctan of tan divided by the cosine, they are further down. Yeah, divide by the cosine, you get a bigger number. Because the cosine is always 1 or less than 1. You get a number that's the same or bigger. It'd be vast if it was 90 degrees, but that would be a mess. I got this right. 0.0046 radians. They are that far below eye level, not below horizon level. The difference is 0.0021. They're that far below horizon level. Which means that the clouds vertically above the horizon at the edge of your field of view will be that far below the clouds vertically above the horizon in the centre of your field of view. In more familiar units, 0.122 degrees. If you have a 90-degree vertical field of view, and I apologise for anyone who's offended by me having a 2 radian by 90 degree field of view. If I called it a 120 degree field of view, you'd probably get exactly twice in there. But never mind, you know. 2 radians by 90 degrees, it's approximately a 120 degree by 90 degree, 4:3 ratio, fairly popular. Right. It's 1.36% of it, which is only 4.37 pixels with this camera's 12 megapixel sensor. If it's taking stills. If you're taking video, it's 1080 video, it's only 1.5 pixels. So problem number 2 is the curvature he's asking why he doesn't see is in a video, wide angle video, a whole 1.5 pixels down at each edge from where it is in the center. So, you know, that might be, it'd be there, but it'd be really, it's tiny. It's not something you'd notice unless you're really carefully looking for it. There's no good saying zoom in on it, because if you zoom in, you reduce this angle from 1 radian to something much smaller, which reduces this cosine to something much smaller, which makes this much bigger, which makes this closer to this, and you end up with this tiny, tiny difference, which doesn't show up at all. So it has to be full wide angle, and which means full wide angle on the vertical as well, which means just 1.5 pixels in video. So that's your second big problem with it. The 0th big problem with his assertion you should be able to see curvature in clouds is that clouds aren't graph paper. They're not at a perfect level. They don't have a crisp base. It's not like the surface of a swimming pool, and it's not grid patterned. There isn't a line going perfectly north-south along the clouds at exactly 3,500 feet. Yeah, you don't have a line of beacons up there, or a rope, or a road, or anything in which to see curvature. There's clouds. They're kind of fuzzy around the edges. They're wispy. They're cloud-like. They're sort of vague. There is no grid pattern on them for you to see curving, and they're not all at exactly 3,500 feet. So your 0th problem is that clouds aren't a thing in which you would expect to see curvature anyway, unless you get one of those really, you know, static layer cloud days and see it curving down over the horizon away from you. But left to right curvature, clouds just aren't evenly spaced in a grid pattern like that. And your first problem is that they're bloody miles away, and the second problem is that it's tiny, because you're tiny and the Earth is huge. Bloody idiot. Oh well, I hope some of you who are more intelligent than Jam Truth, and faced if you're watching this, you're almost certainly more intelligent than Jam Truth, found at least some of that interesting.